Welcome back, everybody. In this example, we have a 90-pound block that is rest on a frictionless surface as shown. Then a 50-pound force is applied to it horizontally as shown. We're interested in finding acceleration of the block, and then in the second part of the problem, the question is what is its velocity and displacement 3 seconds after the force has been applied. So let's start by drawing a free body diagram of the block. Suppose this is the block, and then I want to show the forces acting on it. Well, actually, let's move it a little bit to the right so I have room to show all forces. Let's say this is the block, and then it has a weight of 90 pounds, so I have this force 90 pounds going down, the surface reaction, normal force N, and then the applied force 50 pounds. Since it says frictionless surface, I won't show any friction opposing the 50-pound force, so this net force is not balanced, therefore it causes an acceleration. If I draw a mass acceleration diagram, I have vector MA on it. Net force equals to mass times acceleration in x direction, and observe that this is generally speaking a vector relationship, but I'm taking the scalar component of it in x direction. So if I continue with numerical calculations, I have 50 pounds as the only force in positive x direction equals to MA. Mass is weight divided by acceleration of gravity, 32.2 times acceleration in x direction. If I take this equation and solve it for A, acceleration turns out to be 17.89 feet per second squared. So that's part A of the problem. As far as part B is concerned, we're interested in velocity of the block. Recall from kinematics that velocity as a function of time for the case of constant acceleration is at plus initial velocity. Taking initial velocity to be 0, velocity at 3 seconds is 17.89 times 3. Therefore, V of 3 turns out to be 53.67 after multiplication. This is in foot per second. So that is velocity at 3 seconds. Then the last thing we want to know is what is the displacement of it at this time. So I want to write the position relationship. Recall that position S as a function of time for the case of constant acceleration is 1/2 AT squared plus initial velocity times time plus initial position. Again, if I take the origin to be located at the point when the force was applied to it, initial velocity is 0, initial position is 0, therefore S of 3 equals to 1/2 acceleration is 17.89, T is 3 squared. So doing a calculation on a calculator, I get S at 3 seconds to be 80.5 feet. So that's how I can deal with this constant acceleration example. Let's look at another problem.